This is the transformation of functions worksheet that you have posted as a homework. I'm going to go through parts of it, and then you're going to be expected to complete it and then turn it in for school. So when we talk about transformation of functions, I did the video over the function transformation sheet. So we can take any function, we can move it up, we can move it down, we can move it left, we can move it right. Okay. We can also reflect it across our y-axis, or we can reflect it across our x-axis. And there are different ways that we change our base formula. We can also stretch it and we can shrink it. Okay, so these are all the different transformations. This homework sheet goes through each of these. So what the main thing that you need to know is the very first graph here, this part 1, it says complete the table of values for the graph of the curved segment. This is function fx. So this is our key. So I wrote it here. This is our key. This graph here and these numbers are our starting point. So for everything moving forward, we are referring to this section. This is where we always start, and then we are going to be moving. So these numbers that we get will be the key that we use as we move forward. So if you want to take a picture of this, for me, I did mine front and back. Even if you have separate ones, you need to have this key available as you are moving forward. You will need to have these numbers. These are your answers that you have. Okay, so the way that I got these numbers is we're simply plotting points. Remember, a function is the answer key of coordinate points. So we have our x values and our y values. So when x is -5, so I'm going to find my -5, my y value is 2. So I have simply plotted my coordinate points, and we are writing them down here. So when x is -4, y is 3. You will need to go through and write down your y values for each of these x values. Then this is your key. Okay? So for the next one, it says, this is your new equation. We are taking our f of x. This is our f of x. We are taking this function, and we are going to add 3. So the first thing that we need to look at is on our function chart, we have added 3 outside of our x values. So we are adding 3 to our y, which means that we will be moving our function up. So if we were to cut this out or have it set on top, we would take our base function, our standard function here, and we're going to simply move everything up 3. If I were going to plot it on here, every point I would go 1, 2, 3. 1, 2, 3. We're going to go up 3 on each one, and that would replot it. So if we go directly from the graph, we're going to go up 3 for each one, because that's what it tells us to do. The check for that is to do the math portion of it. The plotting is easy. You just take each point, you move it up 3. We're going to check and make sure that is accurate. So if I have f of x, then I'm going to do plus 3. So here it tells me my x value is -3. I'm going up to my key. They wrote it as y equals f of -3 plus 3. So I'm going to my key. What was the y value for f of -3? I'm looking for the y value when x was -3. So when x was -3, my y value was 1. So I'm plugging that in. That was my answer. So I have 1 plus my new 3 gives me 4. Same thing. Here I have a -2. So I would have f of -2 and then plus 3. So when my x value is -2, what was my y value? X value -2, my y value is -1. So f of -2 is really -1. So I now have -1 plus 3 gives me 2. So for each of these, we are finding what was my y value. So for example, 2. My y value for 2 was 2. So I would plug that in. So now I have 2 plus 3 gives me 5. We're going to fill in our chart, and then we're gonna graph it. Same thing for number 2, it says f of x minus 2. This minus is outside of the x value. So we're looking at this one, a constant outside of the x value. We are simply moving the entire graph down along the y-axis. So we could take our standard function and we're gonna go down to 1, 2 and just replot everything and graph it. So that's how we graph. We're just gonna move all of the points down to double check the math of it. We're gonna use our key right here. So what was the value for x negative 3? The y value for x negative 3 was 1. So now I have 1 minus 2 gives me negative 1. Same thing, what was the value when x was negative 1? When x was negative 1, my value was negative 2. So I start there, negative 2 minus my new 2 gives me a negative 4. So now I have my new coordinate points. These are my x values. These are my new y values. These should match with your graph if you were to take your entire graph and move it down by 2 places, since that's what it said. All right? Fill out your chart, graph it. This one, let's look. Our change is inside. It's inside our function. So the change has happened to the x value. That would be this one. Our change has happened to our x value. Okay, so we're gonna have new x values here. Okay, so when we have new x values, it says, whoops, we are going to take our original graph. So this one says x plus 1. We know that adding something is really a move to the left and a negative. So we would take all of our points and we're going to move them over 1, which means that the part of the graph that now crosses, let's say, x negative 3 is going to be a different part of the graph that would cross at that point. Okay. So we're gonna find out when x was negative 3, let's look back out of it. When x was negative 3, I had a 1, right? But we're not doing that one. We are doing when x was negative 3, but I'm adding 1. So what we're really looking at is when f of negative 2, when x was negative 2. So now my x value is negative 3, but I'm gonna take my negative 2 value. My negative 2 value is negative 1. So that is now my answer. So let's look at this one. My x says it's negative 2, but I don't want to find the answer for negative 2. I want to find the answer for negative 2 plus 1. So negative 2 plus 1 is negative 1. Now I'm going to look along my key and say f of negative 1 was negative 2. So that's my answer. Okay, the reason that we're doing that is we have, just to go over again, we have our graph, we are shifting it to the left by 1, which means that at this point, where this point typically crossed, let's say y is 1, it's not going to be at negative 3 anymore. It's going to be at negative 4. So we're moving our x values. So we have the same y values. So what you will see is that these answers here will be the same values that were on our original y. They're just going to be lined up with a different x value because we have shifted our answers along our x-axis. Okay. So for number 4, we have x minus 2. A minus 2. Remember, if it was equal to 0, because we're looking at when y equals 0, this would be x minus 2 equals 0, x equals 2. So we are shifting a positive 2. So we will take our graph, our original graph, and we're going to move it 2 spaces to the right. So all of your points are going to be moved 2 spaces over. So take this original graph, move everything 2 spaces over. We're going to double check with our math. So when we're at the same y value, let's work through this one. y equals f of x minus 2. So it says that x is negative 3. So I am looking for negative 3 minus 2. So I'm actually looking for f of negative 5. So when x was negative 5, y was 2. So my answer is now 2. So in this shifted portion, when x is negative 3, my y value is 2. So at 3, I'm going to have 2. Negative 3, 2. We have moved it over. So again, we're going to have these same y values. They are just going to be lined up with a different x value because we have moved them.